Welcome back to Arxflix. Today, we're diving into the innovative research behind OpenFlamingo, an open-source framework for training large autoregressive vision language models. This paper introduces a family of models that span from 3 billion to 9 billion parameters, aiming to replicate DeepMind's proprietary Flamingo models. Here's a chart illustrating OpenFlamingo's performance relative to Flamingo across multiple vision language datasets. On average, these models reach 85 to 89% of the performance of their closed-source counterparts. Vision language models typically map an image and text to textual outputs. While this is great for tasks like image classification and VQA, it limits flexibility. Autoregressive vision language models, however, handle sequences of interleaved images and text. These models can enable in-context learning, multi-round interactions, and generalize well across tasks. But up until now, they have been proprietary, limiting academic research. This is where OpenFlamingo comes in. OpenFlamingo replicates the Flamingo models by augmenting pre-trained, frozen language models to cross-attend to outputs of a frozen vision encoder. Training data comes from open-source datasets like LANT and multimodal C4. Here you can see OpenFlamingo processing an interleaved image and text sequence. This design allows the model to tackle various vision language tasks through in-context demonstrations. The models use dense cross-attention modules attached to the layers of an autoregressive language model. Image embeddings are extracted using CLIP as a vision encoder. Text sequences are processed by marking image locations with tokens like image and in-dofchunk. The training data includes both image-text pairs from LANT and interleaved sequences from multimodal C4. The models are trained using a mixture of image-text pairs and interleaved sequences, sampled using the web dataset format. For example, a line is replaced with LANTB, a dataset of 2 billion image-text pairs. Similarly, M3D is replaced with multimodal C4, used for creating interleaved image-text sequences. OpenFlamingo models are trained using 64 GPUs, optimized with Atom, and evaluated across 7 vision language datasets, including COCO and VQ2. The initial reduction in language modeling loss is followed by slower decreases, attributed to the nature of MMC4 sequences. Performance is evaluated using standard metrics like CIDR for captioning and VQA accuracy for visual question answering. The models are compared to both Flamingo and fine-tuned state-of-the-art models. Here's a comparison of OpenFlamingo and Flamingo models across different in-context example settings. OpenFlamingo models achieve around 86% of the performance of corresponding Flamingo models, with some models even surpassing their proprietary counterparts on certain tasks. Taking this further, OpenFlamingo averages over 62% of fine-tuned state-of-the-art performance with 32 in-context examples. Interestingly, models with frozen embeddings underperform, as shown by the drop in performance for OpenFlamingo 4B. Validation trends show stable improvements in COCO performance, but stagnation in VQ2, suggesting language model choice has a crucial impact. Models like Otter and multimodal GPT have already been developed using OpenFlamingo. However, given they are trained on web-scraped data, they carry risks of unexpected or inappropriate outputs. Further safety investigations are crucial for future iterations of these models. OpenFlamingo provides a powerful open-source alternative for training and studying large autoregressive vision language models, enabling a wider academic engagement. The technical details, models, and code are freely available, opening pathways for future research and innovation in this exciting field. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.